Hello everybody, this is Ward Bell of IdeaBlade with a video episode on one of our samples, CodeCamper JumpStart Ruby, that demonstrates building a single-page application with Breeze.js and Ruby on Rails. Why Ruby on Rails? Have we lost our mind? Are we abandoning .NET, which is where most of you think we live? No, we have no intention of doing that. What we are interested in doing is demonstrating that Breeze.js is first and foremost a library for building single-page applications made up of HTML, CSS, and JavaScript. And as such, it can speak to any variety of back-end technologies, whatever you would choose. We picked Ruby because it's a popular way to write server-side logic, and justifiably so. And we want people in the Ruby community to understand that Breeze.js is as much for them as it is for .NET developers. Now, if I am a .NET developer, I might say, so what's in this sample for me? I have no intention of using Ruby. What am I doing here? I think it's very useful for you to look at this sample as well, particularly if you have looked at Breeze as we've usually presented it in context of what we call the productivity path involving SQL Server, Entity Framework, Web API, and then you get to the client. You may be in the camp of .NET developers who say, I don't use one of those technologies on the back end. I don't want to use any framework, or I don't want to construct my server in the manner in which you have shown it to me. I want to have a more REST-like controller. And I say to you, well, some of those kinds of things you're going to see right here if you hang in there with us. So I hope you'll come along with us on the journey. We're going to be showing you a client application that was built actually for a .NET stack, and we changed it just ever so slightly in some very specific places so that it could talk to a Ruby on Rails server instead of a .NET server. That Ruby on Rails service component is written in straight Rails. There is no special Breeze.Ruby components that you have to buy into. A Rails developer should be able to look at it and say, aha, this looks familiar to me. I know where to go with this. And of course, that would mean that the way in which the client talks to the server would have to be using some kind of a REST-like API. It can't be the kind of RPC API that we routinely show when we're showing the Breeze productivity path that you're perhaps used to. One of the interesting artifacts of this particular demonstration is that the data management and API and business logic, all that stuff is written in Rails, and there's a Rails server for that. But the HTML and CSS and JavaScript are actually served from a completely different server. We wanted to isolate those two issues, and while we could have served those other assets through IIS, we thought, well, you know, they don't want to see that. They want to see something different, so let's serve them up with Python. That means that there's no Microsoft in this demonstration at all, and I want to therefore make a very important point that it's not that we're anti-Microsoft in any way. What we're trying to establish here is that if it works in Ruby, it can work for you no matter what technology you choose. The point of origin, it was a sample application written for the .NET stack. In this case, it's John Papa's Code Camper JumpStart. There's a great course by John in Pluralsight, highly recommended, the link's in the lower left, in which he takes you through building a SPA with a particular stack of technologies that includes, on the client side, Knockout and Durandal and Breeze. The actual original code is available at the link on GitHub on the lower right. And if, I'll hover over here, if you were to go to that link, you would find yourself seeing this application running in Azure. Now, CodeCamper, it's an application. The backstory is that you were an attendee of a code camp and you'd like to look at the sessions that are available there and the speakers giving those sessions, and you'll see there's some editing capabilities as well. We're going to look at that. It seems sort of like a perfect way to take a sample designed for a .NET backend and swap out that backend and put Ruby on Rails behind it. And that's what we're going to see. Having watched the video, I hope you'll want to run it yourself. Let's assume that you're already a Ruby developer, so you'll go to GitHub and you'll download it using this link here, and then you'll set it up. You'll install the gems. You'll create the sample SQL database per the instructions in the README, and that's all setup stuff. The app has two servers. One of them is the Rails server, so you'll run bundle exec Rails S. And then you're going to launch a separate server to deliver the client-side assets, the HTML, CSS, and JavaScript, as for example here I'm doing with the Python. And now having both of these servers up and running, you will then launch your browser, set your address to localhost 8000, and see the application running like this. Here's the application loading, the splash screen. We got a whole bunch of stuff. These are little toasts that are reporting the activity of it so we can understand what our application is doing. We started by getting some data from a remote data source, that is our Rails server. This data is now in the Breeze Entity Manager cache. And we can see there are a bunch of sessions here. We can drill into any one of them. There it went out and got the full version of that session from the server. If I go back and I go back in again, you'll see that this time it retrieved it from cache and it was a heck of a lot faster. So we can see a certain advantage to keeping information in cache. I can make some changes here, and I go away, and now I have the save button enabled here, and I can try and leave, and it'll say, do you really want to leave this? And I'll say no, but I can cancel it and revert it, and notice it can revert changes. Or I can make the changes and I can save them, and now it is saved and I'm still ready to edit. But if I go back over to the sessions, you'll see I've actually got that information in my sessions list. I can go back into that again and fix it, blah blah, and save it, and we're all good again, as you might expect. The application also can get at the speakers. Scott Guthrie here is a speaker, and this information happens to be held in cache, but it can be refreshed as any data can from the remote data source at any time. So you get to choose either programmatically or by button how fresh you want the data to be. And what you're also seeing here is that they were really kind of pivoting over the data. So we have Scott Guthrie, it's the same Scott Guthrie here as a speaker. And then when I go back to the sessions, there he is in the sessions display. We can add a session, create a brand new session if we try and save it. Baked in Breeze validation detects that we violated some rules about what our required fields are. And so the save was stopped. So we must put something in. Let's do that. Let's satisfy it. I'll go to the track and pick a track, say it's cloud. Now this is a list of entities that were retrieved at some point independently of the sessions, and yet Breeze is able to unite them in the cache and navigate from a session to its track or to a time slot. And we can go fill in some of the others, the room. Need that. We can get the person, which will be Aaron here, and I can save this work, and it saved it, and I'm ready to edit again if that's really what I want to do, or I can see that it's in the session list. I did not make a trip to the server because I know about this one. He's already here. He is actually out there in the server as well. Or I can come back and I can delete it, and I can, yes, I really do want to delete it, and away he goes. Let me say again, I want you to watch this. As I refresh, you'll notice that it says it retrieved session partials from a remote data source. This captures the probability that you were in building a list of real data. You wouldn't be able to afford to bring everything down about all the things that you were showing. So we can do a kind of a Breeze trick here where we do a projection, where we select some data, we pull it down using Breeze, but then we say, you know what, let's pretend that these are entities. I know they're missing something. We'll remember that they're missing some data, but let's hold on to them. So they are partial entities. Now when I try and edit this, it realizes that that's not complete, and so it goes out and makes a trip and fills it in, so we get the information that was not brought down in the partial case. And then we go back and we look, and you can't tell by looking at this list that Scott is a full entity and Colleen's is a partial entity, but the application knows, so that when it comes here, it knows to get it from cache, And when we look at Colleen's, it will know that it had only a partial and it had to go get the remote stuff. All of this is happening as part of the Breeze management of data, and you're just busily binding away to it. And I think that's enough to give us a feel for what the application can do. Let's go see how it does it. Here is the big picture application architecture, starting with a client, which is really exactly as John wrote it for his Pluralsight course version that was backed by .NET. There is the user interaction surface implemented in HTML and CSS, and also Bootstrap, and that's supported in JavaScript by the application code, but also this thing he calls the hot towel stack, made up principally of 3 third-party libraries: Durandal, Knockout for data binding, and Breeze for data management. Where it gets different is on the server now, where we're using Ruby, as we said, and Rails, and the database is MySQL instead of SQL Server. And because we decided tactically, it's not necessary, but we decided tactically to have Rails do only the data and business logic, there is also a second server which would deliver the HTML, JavaScript, CSS, and images, which could be anything you want. In our illustration here, we're using Python. Let's start our tour with the Ruby on Rails server. The CCJS Ruby application is divided into the client side and the Rails side, and so we have 2 folders for that, and we're looking at the Rails folder. Let's get the configuration part out of the way. So we've got a database.yaml to help us locate the MySQL database, and we have a roots.rb to handle the requests that come from the client and route those requests to the appropriate controllers and methods in those controllers. For you Web API folks, that's a similar concept to the routing with which you're familiar. Now we're going to need Breeze metadata. Every Breeze application does need Breeze metadata, which describe each of the entities, both their data types, their properties, and certain characteristics about them, just so it can operate properly with them. In this example, they're found inside that initializers folder in the settings.rb file. And if you look at that, you can see that's just a big chunk of JSON. If you were back in the .NET world following our productivity path, you might expect this JSON to be generated out of the entity framework metadata. But here, of course, we're not using entity framework. So we have to get the metadata in some other way. Now, we could have done that in JavaScript on the client. What we're doing here is we're just preparing this JSON and holding it on the server and shipping it down to the client when the client asks for it. But that's developer's choice. Rails is a model view controller paradigm. So the app folder has controllers and models and views. Let's start with the controllers. There's one sort of overarching application controller, and then there's specific Breeze application controllers. Looking at this application controller, the most interesting thing about it is that portion of it that's dedicated to supporting CORS, the cross-origin resource sharing. We need that because the Rails server is at one address, and the client-side assets, the HTML, CSS, etc., are at a different server address, and the browsers are prohibited from doing cross-origin AJAX calls unless we do something like CORS here. For model view controller, let's look at the models, and some of these I hope are familiar from our example, sort of intuitively. This is sort of the Rails definition of our entities. What we're looking at here is the session entity. That it has related rooms and time slots and tracks, and these are other kinds of entities, and the speakers that you may remember, those are actually persons. If we look at the sessions controller, we see that the full range of typical REST-like requests map into methods of the controller. The get all goes here to index. Whenever you ask for a specific one, blah, 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 session/ID, something or other, that goes to the details method. And then we have put, post, and delete methods to deal with adding, creating, and deleting entities, or session entities in this case. The index method, which is the sort of get all method, is especially interesting because it has sort of two modes. It can either deliver all of the sessions, or it can deliver what we call partials or projection, which is to just say that we're going to select certain attributes, certain columns of the data, and send only that. Which the method does depends upon whether the client sends a $select parameter that specifies the attributes that it wants when it wants partials. Now, it turns out this application only ever hits this method when it asks for partials, but it's prepared to deal with either kind of request. The join there at the bottom to speakers is there for ordering purposes, because the client can ask Rails to sort things on the data tier rather than try and do that on the client tier. And it does so by passing a parameter as part of the URL that specifies that order, and that order might involve speaker information. So we have to do the join for sorting purposes, but in fact the actual data ship will only be session information. What you're seeing here is the specification of a view for each of the kinds of request methods, the index, the get the details by ID, and so forth. Now here you got to think of a view not as HTML destined for the user, but rather as a view that describes the payload, a JSON payload, ultimately that will be sent to the Breeze client, because it's Breeze that is the consumer of the view, not the end user, and Breeze is expecting it to be as these JSON objects. There are two special kinds of requests that can come from the client. Both these requests are routed to the settings controller. The metadata one will take that big JSON object and send that string back down to Breeze so it knows what to do. And the second request is something called lookups. This is kind of interesting, a little unusual. Of course, the client could ask for the rooms and the tracks and time slots separately. There could be controllers for each of those. But that would mean 3 separate little trips. You can imagine if you were starting up an application and you had hundreds of reference lists, that might not be the best performing or most reasonable way to do it. So what CCJS does, and we're facilitating here, is it says, let's take all these reference lists and throw them in one big pot. And we'll send them all down. We'll make a single request, get a single payload of all this information back, and we'll let Breeze sort it out into the individual entities to hold in cache and to do what it needs to when it needs to, such as populate individual lists. It's kind of cool. It's something that Breeze facilitates, and we take advantage of it in CCJS. And here's the view that does the packaging. You know, there's a sort of top node called lookups, and then there are these 3 child nodes, which are the arrays of the 3 kinds of reference lists we're sending.
So that's our Rails code. Now remember that our client-side application, we don't want to change that. We want it to be the same on the front end, whether it's pointing at a Rails backend or a .NET backend. But Rails is not the .NET backend that we're used to showing. It's different. And those differences are most apparent when we see what is passing over the wire. For example, the serialized payload in the response to a client request will be different. In this example, we're looking at the session object sent back in response to a query, particular kind of query. We're asking for only some of the attributes of the session. We call that a projection or a partial. Here's what it looks like coming from a .NET backend. And you can see immediately, just visually, that there are some differences here. For example, there is no $ID node property. By the way, they both have IDs. Those are the IDs of the objects. But what's missing is the $ID node property, which describes the package. And that's missing from the Rails side because we're not going to use it on the client side, so why bother creating it? We are creating and sending the $type node because that's the most convenient way for the Breeze client to distinguish data for one entity type from another. So, for example, to distinguish a session data from a speaker's data. We've asked Rails to produce it for us, and we're in complete control, so we can come up with a nice name like CodeCamper.SessionPartials. But when we ask JSON.NET to produce it for us automatically on the .NET side, well, it turns out a projection delivers an anonymous type, and so we're getting the ugly.NET anonymous type name. And we don't really care, but it certainly is nice to see the difference when you're looking at the wire format. Probably most important is the property names. You know, everybody has their own property name convention, and in Rails it tends to be all lowercase with underscores to sort of separate the words. So you get time_slot_ID. And in the .NET world, it's more typical to use Pascal case, so you get time slot ID one word. And it turns out on a Breeze client, because it's JavaScript, the convention there is camel case, so it would be lowercase t in time slot ID. So we have these three different ways of representing it. What we need is a way to map from one to the other, and Breeze provides that. A big difference is in the API itself. You see, Rails favors a REST style of communicating between client and server, in which you use the HTTP verbs to specify a single operation, and you target a resource, a very specific resource. In this case, we're editing, so we're using a put, and we're changing the session with ID 1, which is represented as session/1. We've chosen for our implementation to only send the changed property values. We don't send anything that wasn't changed. And that's different than the most common Breeze.NET view, not the only possible one, but the most common one, because Breeze likes to, by default, send a change set whenever you make a save. So in this .NET example, post to a save changes method rather than use special HTTP verbs to target individual resources. But we're also able to make simultaneous changes to multiple entities at once. So we're sending a change set bag. And you'll notice that, again, by convention, the default behavior is to send everything about the entity, which may be helpful on the server side, rather than just cherry pick those values that need to be sent. So we see that the Rails server has its own way of doing things that doesn't exactly fit the Breeze default client. And that's going to happen a lot, whether it's Rails or some other server-side technology. We don't want to force the developer of the server technology to meet some supposed Breeze standard. We want you to code the server the way you want to code the server. And so we have to do something, and the way to do that is to adjust the Breeze client for the Rails API.
There are several Breeze extension points for marrying the client to a particular service, like the Rails service. 4 of them are on exhibit here. 3 of them are adapters. There's the AJAX adapter for issuing calls and processing some results via AJAX, and it's very low level. There's the data service adapter, which is a higher level. It translates abstract Breeze Entity Manager operations into the general direction of whatever the service is, in our case a Rails service, and it kind of mediates between the Entity Manager and the AJAX adapter. There's a JSON results adapter which takes the JSON data, it's almost always JSON data coming from the server, and morphs it a little bit so that Breeze can chew on it better. And part of that process happens so frequently, that is to say the mapping of property names between the client and server, that we have a special component called the naming convention for dealing with that. We'll acquire and configure the adapters first. And we'll do that in the data context service. This is an application service module. It's created very early when the application starts up, and it provides the abstraction for the view models of all the business of getting and saving data, and it keeps Entity Manager and all the Breeze stuff pretty much at arm's length. And that's a good practice. Because this is a hot tile Durandal application, we will inject these adapters when the data context module is first built. Now, actually, only one of the adapters is a model that has to be injected into the definition function, and that's the JSON results adapter. The other 2 are Breeze plugins, so we can get to them in a couple of seconds by accessing the Breeze namespace itself. But here we are initializing the JSON results adapter, and then we're newing up an AJAX REST interceptor and enabling it. And then we will grab the active record data service and tell Breeze that it should be using that when this client is talking to a remote service. We're not actually replacing the default AJAX adapter in Breeze so much as what we're doing is getting the existing one, and we're replacing its AJAX method, its primary method, with an intercepted version of it. And we're only doing that so we can intercept the Breeze's typical way of getting an entity by ID, which is with an OData filter expression, such as you see in blue, and turning that into what Rails is expecting, which is that the ID is part of the URL, the resource specification, as you see in red. That's all we're really going to do in there. We are going to completely replace the default data service adapter, because the default data service adapter, when it sees your code tell the Entity Manager to save changes, It's going to ask the entity manager for all the entities with pending changes. It'll gather them up in a change set, a kind of bag of entities, and it's going to post them to a particular endpoint, probably called Save Changes. But that's not the way Rails wants to do it. Rails wants to see individual operations for individual entities. Put, post, or delete of a single kind of change going to a particular endpoint that maps to an entity type controller. So that's what we do here. It's not terribly hard, it's just different. You may remember that the CCJS application, when it asks for all the sessions or asks for all the speakers, what it's really getting back is a portion of the session each time. It's getting just a few of its attributes. It's getting a projection of the attributes. And one of the tricks in this application is that we, for a while, pretend that we actually got the full entity, but we mark that entity as partial so that when we try and edit it, we'll know to go back and get the missing pieces. Now, we do that by setting a flag, the isPartial flag, and we're doing that on one line here in the JSON results adapter where we look at the $type node, which is the name that describes the data we just got, the data we were just evaluating. And if the word partial is in there, we know it's partial. In any case, we take the node, the JSON data, and we pass it on through and let Breeze continue on with transforming raw JSON data into entity data. This is a JavaScript application, and we follow the JavaScript convention for property names, which is camel case. Whereas back on the Rails service, we're following the Rails convention, which is all lowercase with underscores separating the word parts. Now, if we're going to talk to the client or we're going to talk to the server, we've got to speak its language. We got to translate between these property names, and this problem comes up so frequently that Breeze has a component for that called the naming convention, and you just write one. It has a to-server method and a to-client method, and you can do it programmatically as we've done here. Let's recap what we've done. We started with CCJS, which is a Breeze.js client single-page application that we didn't even write. John Papa wrote it, and it happened to target a .NET backend. We replaced that .NET backend with a Ruby on Rails server, which we coded in the most vanilla way possible. There are no Breeze.Ruby components, not that there's anything wrong with that, but we decided to go vanilla. Now that means that the API is a REST API, not the kind of RPC style that would be more familiar to the Breeze.NET developer, but it doesn't really matter. We can adapt to that. We can have the client adapt to that with just 4 Breeze.js extension points. And it was a small amount of code, and it didn't intrude into the rest of the application. I know we're talking about Ruby on Rails here, but a really big takeaway is that you can apply these same principles and these same tactics to target any kind of HTTP backend that you want to hit. It's all Breeze on the client. 3 final thank yous, beginning with Ruby Tribe, the Ruby consultancy that built our Rails backend. Thank you, Ruby Tribe. And thank you to John Papa for the use of his CodeCamper JumpStart. We encourage you to go to Pluralsight and watch all of John's single-page application courses, including the JumpStart. And finally, thank you for watching this video about Breeze and Ruby, the CCJS Ruby sample. We wish you all the best in building your single-page applications with Breeze.